Hey guys, in this video, we're looking at the first of four lessons we're going to do dealing with conic sections. First one we're looking at is circles. This is 6.3. So we actually have objectives today. In this lesson, we're going to do graph circles, just circles. See, my objectives are already wrong. And we're going to find the center and radius of a circle. All right, so what are conic sections? So this right here, this hourglass looking 3D shape is called a conical surface. And I can slice this conical surface to make four different shapes depending on how I slice it. I can slice it perfectly horizontally, that's what will make a circle. I can slice it perfectly vertically, that's going to make what's called a hyperbola. I can slice it at an angle and go off the top or bottom, that'll make a parabola, or I can slice it at an angle that doesn't go off the top or bottom, and that'll make an ellipse. Now that probably doesn't make a whole lot of sense. So let's go a little picture of what I mean. So this picture shows four ways of slicing it. And if you kind of see the shape it makes, the one on the left is a circle. The second one is an ellipse because it's kind of like an elongated circle. The third one's a parabola. And then the fourth one is like two different parabolas. We call that a hyperbola. And this picture probably better shows that. So circle in red, ellipse in yellow, blue parabola, and green hyperbola. So these are our four conic sections. We're going to spend one day for each of these. So today is circles, and we'll look at this picture each day we look at them. Now, this is our equation of a circle. Circles are pretty simple, by far the easiest of the four. So here's a circle, got a picture. We have a center. The center of our circle has a coordinate point. So it has an x value and a y value. We call the x value h, and we call the y value k. And we're going to see h and k used as far as x and y for the center in a lot of our different conic sections. So that's going to be the norm for us. And then the distance from the center to any point on the outside of my circle is r, or radius. That's something you learned back in geometry and probably in middle school as well. And so we had this equation right here. Now, you should already have this paper right here, okay? Our conic sections formula sheet. We use the back of it, the formulas on the back in lessons 1 and 2. Well, if you notice at the top, this top box is parabola, we got ellipse, we got hyperbola. And while it says something about circles at the bottom, there is no box for circles. So we're actually going to add circles and we're going to put it in this notes section right here. All we're going to do is just put this equation. So this equation right here is going to go in my notes section. So I'm going to pull that back on the screen and I'm going to add it. Okay, so I'm going to take that formula. I'm going to add it. So, okay. X minus 8 squared plus y squared. Now you might want to write that smaller so you can put more notes in there, but really this is about all you need to put on here. Off to the side, I'm going to say, okay, the center, h comma k, and then r equals. There you go. That's what you need in the notes. And that's the only formulas that we have for today, just that one formula. So now let's look at our paper and see how we do these with our problems for today. So we're going to do 6 problems together. There's 3 different problem types that we're going to do. So we'll do one of each type. Spaces. Okay. So first thing we're going to do is we're going to come up with the equation of a circle given the center and the radius. All we're doing is just plugging these things into our formula. So we'll identify what's h, what's k, what's r. Well, there's h, there's k, there's r. So let's plug in. We're going to do this in the 2 steps. And we'll have a little simplifying step, very, very small simplifying step. So I have x minus 12 squared plus y minus negative 13 squared equals 3 square root of 2 squared. Okay, so that's just plugging the values in. Now I'm going to simplify a little bit. First one, x minus 12, nothing I'm going to do to simplify it. I'm not squaring that out, leaving it just like that. Only thing I'm going to do on the next one is I'm going to change that minus negative to y plus 13. Okay, and what you're going to notice very quickly, because we're going to see this kind of patterns pop up, is that if this is positive, this is negative. This is negative, this is positive. Okay, opposite sign. That's not the first time we've seen opposite signs. All right, and then the last thing I'm going to do to simplify is just simplify my square root. Now to simplify this, do this over here to the side, I'm going to square these individually. If I square the 3, well, 3 squared is multiply. If I square root of 2, root of 2, well, root of 2 squared. Well, if I square root, the square and the square root cancel out, I get this 2, and 9 times 2 is 18, so it could be number 18. And that's it. That is the equation of a circle that matches number 1. If you're feeling super confident, you can go ahead and see if you can get to the answer of number 2. Exactly the same thing for number 2. In fact, I'm going to leave kind of green, plug into. So my center, I have parentheses x minus 16 squared, y minus 14 squared, and my radius is 2. Well, there's actually only one thing I can do to simplify this. X should not magically turn into a y. There we go. Only thing I can do is say 2 squared is 4. And that's it. Now, at this point in time, you're asking, do I have to write the green step? Can I go straight from here to the pink step? And the answer is absolutely. Go right ahead. I will do it too, but I'm trying to make sure I show all my work for the video. So yes, you're welcome to go straight to the answer. All right, so go ahead. That was 1 and 2. Go ahead and try numbers 3 all the way through numbers 6. Right. So I'm picking up with numbers 7 and 8. Okay. Now, what makes this one different is that I have a center and I have a point on the circle. I don't have the radius. I need the radius. And there's 2 ways you can do this. You can do what's called the distance formula. The distance formula you learned back in geometry is this. Now I'm going to draw a little picture of what we got here. So we got a point on my circle. The center is at -1, 11. And I got points somewhere on the outside of my circle. And it's at 2, 13. So like right about there. 2, 13. And we're trying to find that length of that line that we connect them. So that's why we would do our distance formula. But here's the deal. My equation doesn't really care what r is. We want to know what r squared is. Okay? So the distance between those 2 points will give me r. I'm going to erase the b there, and I'm going to write r. But I actually don't care what r is. I want to know what r squared is. Let's go and square both sides. And if I square the right side of my equation, well, that square and that square roots cancel out. And now I'm looking at it like, wait a second, this is the equation for a circle. My equation for the circle is distance formula. Let's rewrite it. Our equation for our circle, the r squared first, is x minus h. Y and k are both y values. X and h are both x values. Okay? So really, you don't need a new formula for these problems. We're still using the same formula. We're just plugging in for different numbers. I don't know what r is, so I'm not going to plug in for it. H and K are my center, so I'm going to keep those the same. I have a -1, so I'm going to put a +1. I have an 11, so -11. Okay, well, now I'm actually going to plug numbers in for x and y. I'm going to use my point on my circle as my x and my y, okay, because that's what they are. They give me any point on my circle. So I'm going to plug in 2 and 13, and I'm going to figure out what r is, or r squared. So I'm going to erase my picture. So root 2 plus 1 is 3. 13 minus 11 is 2. 2 squared is 9. 2 squared is 4. And 9 plus 4 is 13. So again, that's r squared. And you might be like, I don't know what the square root of 13 is, and it doesn't matter. We just care what r squared is. The radius is the square root of 13, but all we care about is r squared. So my final answer, if I just re-plug in, we have x minus h, so that's +1, plus y minus 11 equals 13. We just plugged in the 2 coordinate points into our equation, solved for r squared, and then we're able to write our final answer. All right, once again, feel confident, see if you can beat me to the answer of number 8. All right, so I'm just going to skip straight to the point where, right here, I have my equation. I'm going to put the r squared on the other side, because that's how we normally write it. I have x minus h squared plus y minus a k squared equals r squared. And slugging in my values, we have x, y, h, k, right? So I have 17 minus 3 plus -2 minus 3 equals r squared. 17 minus 3 is 14. -2 minus 3 is -5. R squared. And so I need to actually square those and figure out what they are. 14 squared is 196. 5 squared is 25. Add those together, 196 plus 25, 221. So now I'm write my final answer. That's x minus 3 squared plus y minus 3 equals 220. Yeah. So that should take you all the way up through problem number 12, which I think finishes off the page. All right, and so that brings us to our very last type of problem, numbers 13 and 14. So number 13 and 14 go backwards, at least, well, no, I take it back. They really don't. They're exactly the same as what you did on the front. The only difference is instead of explicitly telling you the information, they give it to you as a picture. Okay. Now, the hardest part of this is just figuring out where the center of your circle is. If you can figure out where the center of your circle is, the rest should be pretty easy. I don't think that should be hard either, but sometimes people struggle. So, to figure out the center, I'm going to find the very top of my circle, very bottom of my circle, the furthest rightmost point, the furthest leftmost point. There we go. Now, once I find those, I think, okay, I'll just draw a line straight through the middle of my circle. There is my center. My center is located right there. So what's the coordinate points? The center is located at 2, 1. Right. So there's my H. There's my K. Out of the center. The other thing I want to know is the radius. I don't need to do anything weird. All I'm going to do is count. Okay. How far is it from here to here? Or the top, or the bottom, or the left? Doesn't matter. Well, it's 1, 2, 3 units. The radius is 3. And so now I can plug into my formula. I can say, okay, the center H and K, there's my R, so we have X minus 2 squared, Y minus 1 squared equals my radius. Now my radius is 3. Don't write 3. You have to write our radius squared, which is 9. All right, hopefully you're feeling confident on that one. Go ahead and see if you can beat me to the answer of number 14. All right, so center of my circle located this way. This one should be pretty obvious. First one, right there. 4, comma, 1. There's H, there's K, and the radius is 1. Now, just like on number 13, it has these little lines in the middle. And those sometimes trip people up because they'll be like, oh, I skipped over 2, so it's 2 boxes, so the radius is 2. The lines in the middle are going by halves. They're really just to distract you. They have no other real purpose. So the radius is 1. Plug into my formula, I have X minus 4, Y minus 1, and my radius is 1, and if I square 1, I get still. And that's my answer. 14, and with that, you should be able to finish the paper. And yes, at this point, hopefully you're finishing really quickly, because this is a really quick and easy lesson. The rest of the content sections will be longer, fair warning.